Alright, today we're going to be talking about an rational number versus an irrational one. So when I think of something that's rational, it would make sense. The number that, you know what, I know it's going to end, maybe it'll repeat, but at least I know what's coming. So with a rational number, it's going to be one of three things. You either have a whole number, 1, 2, 3, 4, that's rational. It could be a decimal that ends, so 0.5, 1.5, 3.3, or it could repeat. We'll see those examples right there. If it falls under one of those three categories, it is rational. What happens if it doesn't fall in any one of those categories? So we would know it would have to be a decimal, but it would be some random numbers that really follow no pattern, and it doesn't end. That would make that irrational. All right? So let's come up with a couple examples right here. 5 would be rational. It's a whole number. 5.5 is still rational. It's a decimal that ends. What happens if I have 5.1634 ... At this point, it becomes irrational. Unless I know that number is repeating, which I don't know that, it's going to be irrational. So what we're going to do is we are going to go through each individual example, sum together, sum on your own. We are going to determine whether or not they are rational or irrational, but we're also going to explain why. The big thing for algebra for next year is being able to explain why. So the first example we have is 3. 3 falls under a whole number. Whole numbers fall under it being rational. This is rational because 3 is a whole number. Boom, done. That's it. Next up, 1/2. So if I were to do 1 divided by 2, I get 0.5. Even though it's a decimal, it ends. So we are going to write that it is rational because the decimal ends. I could add as many zeros as I want to at the end. It's still going to end. Those zeros do not mean anything. 11 over 9. Now we're going to make it a little bit tricky. So in my calculator, I'm going to do 11 divided by 9. And this is the answer that I should get. And if I had more space, I would write more 2's. So the way that I'm going to write that, and you're going to see this a little bit more often, is we're going to have a bar that's over it. If I see that bar is over it, that tells me that we're going to be repeating. So if I had all the space in the world, I would be writing more 2's. And because I know it repeats, because we have this bar right here, we can tell that it is rational. Because the decimal repeats. We're done. We're good. Let's do number 4. 11 divided by 7. Same thing. Whenever I see a fraction, do the division. What is that number? That's a fraction. Or that's a decimal. That will tell me whether or not it's rational or not rational. 11 divided by 7, 1.571, 428, blah, blah, blah. Does it repeat? Nope. Because the next numbers I would have had would have been 5, 7. Just looking at this. Doesn't end, because ... Doesn't repeat, I see no pattern. This makes this irrational. Because the decimal, and what we're going to do here is we're going to use our definition, does not end or repeats. That's it. So on your own, I want you to determine if 3.5 is rational or not. The same with 12 over 7. If you have any questions, please let Mr. Perry know. He's here to help.